For my video project, I decided to explain how to solve question 12 from quiz 3, which is as follows. Given the function x cubed plus 2x squared plus 9x plus 18, write it in completely factored form, taking the following steps to do so. Step 1 is to use a calculator to determine a zero. Step 2 is to verify the zero using synthetic division. And step 3 is to determine remaining zeros with algebraic steps from chapter 3. So for step 1, I put the function as y1 in my calculator. I hit the graph button, moved to second trace, and then found the zero as follows. So as you can see, I put my function in as y1. We'll hit the graph button, giving us this line here. It's not the full function, but it serves its purpose in just being on our screen so that we can calculate the zero. So we hit second to trace, which opens up the calculation menu on our graph. And we'll do a 0. And we'll scroll down to do a left bound, right to do a right bound. And we'll do a guess here, which gives us the 0 of -2, 0. So we have that down here. This x value of our 0, -2, will become our c value to do our synthetic division. And we'll use this to prove that this 0 is in fact a 0 of our function. So we take this c value, put it in our corner box here for our synthetic division, and then we set up our synthetic division by writing out each degree, and we'll match the coefficient with each degree down here. So for our degree 3 term, we have a coefficient of 1, so write down the 1. Same thing, degree 2, coefficient of 2, 9, and then 18. So the next part is to follow out the synthetic division. So we start by bringing down this first term. Then we'll move across and multiply by -2. So 1 times -2 equals -2. And then we'll add 2 and -2, which equals 0. And again, we move across and multiply. So -2 and 0 equals 0. We'll add 9 and 0, which gives us 9. And then 9, -2 equals -18. We have adding those together equals 0. So our remainder in this case is right here, equals 0, which means that -2 is in fact a 0 of the function, which we just proved using synthetic division. So that's the second step completed. The last step is to determine the remaining zeros using algebraic steps from chapter 3. So we first have to decode these numbers here that are our quotient and turn it into a equation. So how you do this, so this is degree 3. After completing the division, you subtract a degree, and this is your leading term. So we had degree 3, it's now degree 2, so it would be x squared, and this is our coefficient. So we have x squared, coefficient of 1. Our degree 2 turns into degree 1. So we have 0x, and this degree 1 turns into our degree 0, so our constant, which is 9. So you'll simplify this out. I like to put the 0 just so I can visualize the equation. And then we'll simplify it out, so it's x squared plus 9 equals 0. This equation we take for our step 3. So for step 3, I found that completing the square was the easiest way to find the 0. So I subtracted 9 from both sides to get x by itself, and then square rooted both sides. When you're square rooting a negative, you should notice that the I is going to pop out of the equation, so you'll pull an I out from the square root and then square root the number. So we have our I here. The square root of 9 is 3, Because it took the square root, you want to do a positive or negative here. And these, the negative 3i and the positive 3i, those are our zeros. So we'll take this and this 0 up here to rewrite in our completely factored form. And if you remember correctly, completely factored form is the function with the coefficient. Our coefficient is 1 in this case. And then the x minus c1, x minus c2, and these c's are our zeros. So if we're writing it in x minus c form, x minus negative 2 is basically x plus 2. And then we'll do the same thing with these 3i. So if you do x minus a positive 3i, that means x minus 3i. And then finally, x minus a negative 3i means x plus 3i. And this is our completely factored form, and our problem is complete.